we're still in 1-1, and we're still talking about equations. Now, before break, we talked about an equation that had some fractions in it. Let's do another one that also has some fractions in it. This one we're going to have to multiply, and then we're going to have to clear our fractions. So let's put a 2/3 out in front. And how about 1/7 x minus 2? And then let's say that equals, how about 1/5 with parentheses here times 1/3 x minus 1. So this is what we've got, and we're going to try to solve this again. So we're going to go ahead and try to solve this equation. Now, as we know with our order of operations, what do we always need to do first? Well, we need to get rid of those parentheses first. What are we going to do? We're going to distribute that through. Now, whenever we come up with something that we struggle with, like these fractions, if we need to do extra room, we can write them over to the side. We're going to multiply them, and if we have a hard time keeping track of things, then we're going to divide our paper into sections here. So let's go ahead and divide our paper into sections, and we're going to multiply through each of these fractions. So a technique I use to kind of help us keep on track and not confuse things is I like to draw a line down the middle of our paper. This is going to be our work. This is going to be a clean area over here. So our scratch work is going to go over here, and our steps are going to be rewritten down below here. So our first one we've got to distribute through. And we struggle sometimes with multiplying these fractions, so we're going to write them out. So we've got 2/3 times 1/7 x. So first thing we do when we multiply is we see if we can reduce, cross cancel. Those cannot be cross canceled. So all we can do is multiply across. So 2 times 1 is 2. Down below we have 3 times 7. And that is then your 21 down below. So what do we have so far? We've got 2/21 x. And you can put the x on the top here, or you can put the x behind it here. Doesn't matter. What about the next piece? Okay, the next piece, same thing. We can either do it mentally or we can write it out. For the next part, we've got 2/3 times a minus 2, and we'll make that minus 2/1. Nothing can cancel again, so 2 times a negative 2, that makes it a negative 4. And 3 times 1 makes it a 3. So that piece then comes down is a minus 4/3. Is everyone okay with that so far? So you see what we're doing? Okay.
What happened?
Okay, which piece are we looking at here?
The 2/3 and then in the parentheses negative 2/1. Where did that come from?
Okay, that came from this piece right here.
Oh,
yep.
Okay.
Yep. And always ask if you have any questions. Okay, so I distributed it through and I just wrote it over here. Now, the only reason I wrote it as a minus 2/1 is just so I can keep track and realize that's a whole number. So I just wrote that as just a minus 2/1. And you could have done that mentally if you wanted to and just said, okay, 2 times negative 2, that's negative 4, and I'll just put the 3 down below.
Okay.
But just as kind of a review and refresher for everyone, I wrote it out over here. Okay. But that's just that piece distributed through there. So is everyone okay with the left-hand side? Does everyone see how I got that? So we just distributed through, and that cleared out the left-hand side. Now, what about the right-hand side? Well, on the right-hand side, what do we have on the right-hand side? Well, we have 1/5, right, times 1/3 x. Nothing cancels, nothing cancels. So 1 times 1 is a 1. 5 times 3 is a 15 down below, and the x comes over with it. So that makes that then 1/15x there. Okay. What about the last piece? For the last piece, we've got 1/5. And that's going to be times the -1. And I'm going to make that -1 a -1/1. Just to make it a little bit easier. So you can see what we've got. 1 times -1 is -1 on the top in the numerator. Down below, 5 times 1 is a 5. So now we've got that -1/5 there. Is everyone okay with that so far? Is everyone right with that?
Yeah.
Okay, now we need to figure out how we're going to work on clearing out these fractions. So, what do we have for our denominators? We have a 21, okay, we have a 3, we have a 15, and we have a 5. So, what's our least common denominator going to be? Well, let's start with the left-hand side. Least common denominator, 21 and 3, is going to still be a 21, right? Because 21 goes into 3, 21 goes into itself. What about the right-hand side? The least common denominator of 15 and 5 is a 15. Now we need to figure out the least common denominator of these two numbers, of 21 and 15. And how do we go about doing that? Those are our two largest numbers. Now, we want the smallest number that goes into both of them. So this is just trial and error. And what we do is we start with our larger number. Okay, what's our larger number here? Larger number is 21. Now, let's see if it goes into the smaller one. Does 21 divide evenly into 15? No, it does not. So now let's double it. 21 times 2. That's 42. Does 42 go into 15? Nope. Okay, we're going to keep moving up. So now we take our 21, the larger number, and multiply it by 3. That's 63. Does that go into 15? Nope. So now we've got our 21. Okay, we're going to multiply it by 4. Does that go into 15? Nope, we're getting closer though. How about 5? 21 times 5 is 105. Does that go into 15? Yes, it does. Okay, so what's our least common denominator? 105. Let's again review how I did it. So what did I do? I got the least common denominator on the left, the least common denominator on the right. Then I took those numbers and I found the least common denominator of those two. And how did I do that? I started with my larger number. And I said, okay, 21 times 2, that's 42. Does that go into the 15? Nope. 21 times 3, does that go into 15? No. Times 4? No. Times 5 does though, because 21 times 5 is 105. And that 105 does go into what? 15. So that's how I found it. You take the larger number and you just start multiplying until you find it. You could have went ahead and started with the 5 because this has a 5 in it for the 15. Okay, you could have started there, but if you didn't see it, just take the larger number and start multiplying until you find it. You'll eventually find it. So now we know our least common denominator is what? 105. So that means now we multiply everything by what? 105. And how does that work? Divide by the number down below, multiply by the number on top. You can do it mentally. I'm going to use a calculator so you can see the steps. So what did I do? We take our 105. What do we do? Divide it by what? 21. Yep, divide it by the 21. What does that give you? 5. Multiply it by what? 2 on the top. And that leaves you now with 10x. Divide, multiply. Make sure you notice this is negative. So I'm going to bring my negative down for my next piece here. Now we take our 105, we divide it by 3. And what does that give you? 35. And what do we do with that? Multiply that by what? 4. Okay. So that gives you then a 140. I just brought my negative sign down so I wouldn't have to worry about typing a negative into my calculator. Now we do the other side. 105, divide that by 15. That gives you a 7. 7 times 1 makes it a 7x. You bring the x down. Don't forget you've got a negative here. So that comes down as well. Now we do it again. 105 divided by 5. 105 divided by 5 is 21. Times the 1 on the top. That makes it a 21. Now we have something that we can finish. So now it's easy. Move things around. So let's move the 7x over. Watch your signs. 10 minus 7x, that makes it a positive 3x. We'll bring the 140 down, and it's negative. So we're going to move it over by adding 140. So make sure you add that 140. So now we've got 3x, and we've got 140 minus that 21. That gives you a 119. We're going to divide that by 3. I don't think that we'll reduce it down, but let's double check and make sure. Nope, it's not going to reduce down any. So what's my x going to now be? 119 over what? 3. Let's do one more of these, because these are the ones that students struggle with. The fractions are the ones that we get confused with sometimes on how to clear them out. So once we get these down, then the rest are easier. The decimals we normally don't have trouble with. Square brackets and parentheses we normally don't. It's all about the fractions. So let's do one more of these, and then we'll look at an example of an identity and a contradiction from our textbook. So let's solve another one of these. And again, I'm just going to make up some numbers here. And let's do one where we have to distribute again. About 2/3 times 4/7 x minus 1/2 equals, how about 3 times 1/4 x minus 1/3. Again, I'm just kind of making up some as we go along. We're using some smaller numbers, so they're fairly easy to work with. And this is what you're going to see in your homework. You'll see a couple of these. We want to solve it. So, first thing we do is we distribute through our parentheses, because the parentheses have to be done first. So we're going to distribute through. You can either do it mentally, or you can write it out. If you want to write it out over the side, you can. So we have 2/3 times 4/7 x. We check our diagonals. Nothing cancels, right? So we multiply straight across. 2 times 4 is an 8. 3 times 7, again, is a 21. So that is 8 over 21 x. Is everyone okay with that piece?
Yeah.
Okay. If you have questions, be sure and ask, because we need to make sure we get these down now. What about the next part on the left? Well, the next part is a minus 2/3 times a minus 1/2. Here, what can we do? We can cancel. We can cancel the 2's out, right? Because those can cancel out. And what are we then left with? Minus 1/3. So that's going to come down here. Easy enough there. Now we do the right-hand side. What do we have on the right-hand side? Well, we've got 3, and we can make that a 3. We can make that a 3 over 1. It makes it easier. That way we don't make a mistake. We'll just make that a 3 over 1 times 1/4 x. Okay, nothing cancels. So we just multiply across. And we now get 3/4 x, don't we? So there's that piece. Making sense on what we're doing here. The last one, it's going to reduce down to a whole number. So let's look at it. For the last piece, let me kind of separate these out here a little bit. For the last piece, what do we have? We have 3 over 1, right? Times a negative 1/3. Well, the 3's, they can do what? Cancel. So now we're just left with a negative 1. Is everyone okay with that so far? So all the parentheses are gone. Now what do we need to do? Now we need to clear our fractions, right? Okay. So we can write it down, but what's the least common denominator of 21 and 3? Well, we've done that a couple of times already. That's 21, right? 21 goes into both of them. Now we need the least common denominator of 21 and 4. So what do we need to do? Well, you can either look at it and tell that it's going to be 21 times 4, or we can work it through. Well, does 21 go into 4? No. Okay, 21 times 2, what's that? 42. Does that go into 4? No. 21 times 3, what's that? 63. Does that go into 4? Nope. But what about 21 times 4? 21 times 4 is what? 84. And does 84 go into 4? Yep. So what's our least common denominator going to be? 84. That's how you get them. Just take the larger number and start multiplying until you find a number that's divisible by the smaller one. You can also look at factoring trees, but I think that's too complicated. It's easier to just use our calculator and just go through. Eventually you'll find it. It does not take long to do. So now we know everything gets multiplied by 84. What's our procedure again? Divide, multiply. So let's go ahead and divide and multiply. So what do we have? 84. What are we going to do? Divide that by 21, right? Then what do we do with that? Multiply it by what? 8. And that gives me then a 32x. We're going to go ahead and bring our negative down. And what's the next one? Okay, what do? We take our 84 and we divide it by what? 3. Then we multiply it by 1. And that gives you the 28. Okay. And again, you can just do this mentally if you'd like. You can use a calculator like what I'm doing. I'm using a calculator so you can see all the steps here. Next piece, 84. What do? Divide by 4. Then what do? Multiply it by 3. That leaves you then with a 7. And bring down the x with it. Wait, I think I typed it in wrong. Yeah, I wasn't paying attention. Let's try this again. Okay, 84 divided by 4. I knew it didn't look right. That's 21. And then I divide this into multiply. We need to multiply this by what? 3. My mistake. It should be what? 63. Well, not 7. I divided wrong there. So it should be a 63x. And we've got our last one. 84 times 1. Well, 84 times 1 is just a what? 84. Okay, we bring the negative down. And now we finally have something that we can work with. So, how do we solve it? Okay, we get the x's all by themselves on the left. So move that 63 over. We know our answer here is going to be negative. So we've got 63 minus your 32. That leaves you then with a minus 31x. On the left, we've got a minus 28 and a minus 84. And again, you can do multiple steps at once if you want, which I'm going to start doing here a little bit later. But right now, I'm just doing it one piece at a time so we can get back in a habit of working these out. So what do we do next? We take that 28, we do opposite. So the opposite of a Negative 28 is a positive one. Now we've got a minus 31x. On the left, on the right-hand side, we have 84 and a 28. And 84 minus that 28 is a 56. It's going to be a negative 56. Why? Because 84 is the larger number. And what's the sign of the larger number? Negative. So that tells me my answer over here has to be what? Negative. Now what can we do? Divide by your 31. Do negative 31. Negative over negative makes it then a what? Positive. And that's going to be 56 over 31. And I don't think that's going to reduce down at all. Yep, nothing goes in there. So that's going to be now your final answer. And what type of equation is this? We got an answer. So this would be condition. And I know a lot of us are already familiar with how to solve these, but we need to make sure we have a good foundation. Might have been a bit since we solved equations, but hopefully this has been a good refresher. Now let's look at some more of these. And I do sometimes pick questions from our textbook to look at. So let's try a couple of these to look at. And let's look at question 41. And this is on page 64. Question 41. And if you don't have your textbook, that's fine, because I'm just going to write it up on the screen here. So if you have your textbook, that's fine. If you don't, that's fine as well. So we've got minus 2 times x plus 3. This one doesn't have fractions, but I believe this one is going to be an identity. Equals minus 3 times x plus 4 plus 2. Okay, so here's another one. This one again doesn't have fractions, but this one is going to come out to be an identity. And let's see why this one comes out to be an identity. Well, what do we do first? First thing we do is we distribute through. Now, whenever we have a negative in front, I like to circle it. That way I remember that I'm not just multiplying it by a 2, I'm multiplying it by a negative 2. It's small things like that where students might make a mistake. So that negative goes through. So be very, very careful with the small details like that. So negative 2 times x, that's a minus 2x. Negative 2 times positive 3, that's a minus 6. And then we have a minus x, and we have a minus 4. What about the right-hand side? What do we have on the right-hand side? We have a minus 3x. Minus 3 times 4 makes it a minus 12. And then we have a 2. Before we start moving things across the equal bar, we need to make sure that we can't clean up the sides. And in this case, we can really clean up the sides quite a bit. So what can we do on the left-hand side? Well, let's look on the left. I always like to do our variables first. So we have a minus 2 and a minus x. That makes it a minus 3x. Then we have a minus 6 and a minus 4. Those go together to make it a minus 10. On the right-hand side, we already have a minus 3x. And then we have a minus 12 plus 2. That makes it then a minus 10. Now what do we know? Well, when we look at this, we know these are the same. Yep. And so if these are the same, then this is an identity. And if it's an identity, what do we know our solution set is going to be? All real numbers. And I just want to do another example of an identity, just to make sure we remember that. Let's try to find a contradiction one as well. So that was an identity. Let's look now for a contradiction. How about question 32? want to do the identity first because we covered that one first. Now we're going to look at the contradiction. Okay, so question 32. You've got a minus 6x plus 2x minus 11, and that now equals a minus 2 times 2x minus 3 plus 4. Okay, so what are we going to do? Well, parentheses go first. So let's distribute this negative through. Again, if I've got a negative 2 in front, it's negative, so I like to circle it. That reminds me that the negative goes through. That's a commonly made mistake, and students will forget to do that. So let's go ahead and distribute that through. We've got a minus 2 times 4. That makes it a minus 4x. Minus 2 times a minus 3. Double negative makes it a positive 6, and then a plus 4. Now, what about on the right-hand side here? Okay, so make sure I copied it down right. Let's make sure. Can I copy everything down right? Let's see. Yep, everything looks right there. Okay, just double checking, making sure I didn't make a mistake. Okay, and what about the left-hand side? Well, the left-hand side I don't have parentheses, but I can combine them together, because I can combine those together. Minus 6x and a positive 2x, that makes it a minus 4x. And now what do we know on the right-hand side? Well, the 6 and the 4 can go together, and that makes it a 10. And you can kind of already realize that this is going to be a contradiction. Why? Because both sides have what? A 4x, right? And if I move it over, what's going to happen to it? It's going to go away. And if I move that 4x over with addition, then I've got something that's false, because now I've got a minus 11 equals 10. Well, does minus 11 ever equal a negative 10? Or sorry, minus 11 ever equal positive 10? No. So that would be then false. And if it's a false statement, what do we know? We know it's a contradiction, and it has no solution. So the last one was an identity, and all real numbers. This one is a contradiction, and no solution. That now should take care of most of the questions out of 1.1. Now we're going to move on to 1.2. We're not going to focus so much on the decimals because we're going to see decimals later on. And we've already worked with decimals a lot. I try to cover the topics that I know we struggle with. Decimals don't usually give students trouble. You just use a calculator. So we're really not going to go over that. I chose to spend most of the time on fractions because I know that's where students struggle. So I always try to go through and really emphasize the topics I know you struggle with. Some of the others I may not cover in much detail. And we're going to do decimals a lot in the next section anyways. So now we're going to move on, and we're going to now look at 1.2. And in 1.2, we're going to be looking at formulas and applications. And we need to first talk about equations that are literal. And we're going to talk about what literal equations are, and then we're going to see how to solve some simple literal equations. You'll see more complicated ones when we get to college algebra. But right now we're just going to look at some simple literal equations. And what is a literal equation? Well, by definition, a literal equation is just an equation that has more than one variable. So a literal equation is simply going to be an equation that has more than one variable. a lot of times students try to make these more difficult than what they are. They're really not difficult. Students sometimes look at it and they see all these variables and they get confused. They're really simple. They're going to follow the exact same rules we've used before. On these, though, I'm going to have to tell you what variable I want you to solve for. So here's an example of a literal equation. How about 3a plus 5x equals 9? And I want you to solve, in this case, for a. So I want you to take this literal equation and solve it for a. Now, why is it a literal equation? It's a literal equation because it has more than one variable. You've got a's and you've got x's here. So when I look at this, I need to identify what we're solving for. What are we solving for? A. So I like to take and find the a's, if we have several of them, and put a box around it. In this case, we only have that 3a. So I put a box around it. Now, when we solve, that means that variable is by itself on the left. So what does not belong on the left? Well, the a belongs here, right? But the 5x does not. So the first thing I'm going to do is I'm going to move that 5x over. Now we've got 3a equals minus 5x plus 9. Now we should know what to do. Right? We're solving for a. So I want to get the a by itself. What do we have in front of the a? We have a 3. So how do we get rid of it? Divide. And then we simply rewrite that now as a equaling minus 5x plus 9 over 3. And we leave it as a fraction, just like that. So it's going to stay exactly like that, nothing new. So we've got several variables here. We find what variable we're solving for. We get it by itself on the left-hand side. Let's try another one. We'll probably do 3 of these, and then I'm going to do a couple of them from your homework as well, because there's only 4 of them in your homework. And they're very similar to each other. I'll do 1 of each type. So we'll do 2 more, and then we'll do 2 of them from your homework. How about 4z minus 5x equals 10y plus 8. And let's solve now for z. So again, what's our ultimate goal? Our ultimate goal is going to be to get the z by itself. So let's find everything that has a z. And in this case, it's just a 4z. Everything that does not have a z needs to go to the right-hand side. So what is not inside this box here? The 5x. So I'm going to go ahead and add that 5x over. And now we've got 4z on the left, and that equals 5x plus 10y plus 8. And what's our last step here? To finish this out, can someone tell me what I need to do next?
Divide by 4.
Yep, divide by 4, and that's it. And you leave the fraction alone. So don't try to reduce it. Just leave it as it is.
And that's our answer, isn't it?
And that's going to be our answer. And so now we've got, when we write this, z equals 5x plus 10y plus 8 over 4. How do we know that we are done?
We got Z by itself.
Yep, a lot of times students get confused on these and they don't know when to stop. Well, what are we doing? We are solving. What are we solving for? Z. When I say solve, what does that mean? That means you get that variable, in this case it's a Z, by itself on the left. Now I'm going to introduce another concept, a new concept. Same literal equation, a little bit different on this one. This one's going to require us to use a different concept. And let's go ahead and take this one and let's try to solve this one for y. Okay, so this one's a little bit different, but we're going to use the same concept, and that's an A there. Okay, so what are we doing? Well, we are solving, and what variable are we solving for? Y. So first thing I do is I look at this equation, and I say, let's find all the y's. So there's a y here. I'm going to put a box around it. And minus ay over here. I want to get all the y's by themselves. Everything else goes to the other side. I'm going to try to do this in one step here, so I think it's less confusing if I just do it in one step. So first thing I need to do is let's get rid of the ay. Now it's a negative ay, so I'm going to add ay. So let's go ahead and do that. That gives you 2y plus ay. Okay, those can go together. Now, what does not belong on the left? What have we not dealt with yet?
3x.
Okay, so how do we move that 3x over?
Divide.
Not divide, yep, it's addition, right? So it needs to go over here. So what am I going to do? Subtract off that 3x. And that leaves me then with a minus 3x plus 7. So I could have broke it down into a couple of steps, but I think it actually might be easier if we just look at it in one piece in this one. So the ay went over. So that took care of this. Okay, so that is that right there. And then the 3x went over to join the 7. Now, this is going to require a new concept. What do you notice on the left? These cannot be combined together, can they?
No.
But they have a common variable. Both of these have what variable in common?
Y.
So let's factor out, or take that y out and put it in front. So if I factor out that y, because both of them have a y, that leaves you then with 2 plus a. And this is the most difficult problem I think that you're going to encounter, is one of these. We're almost done. What do we want? We want the y by itself. So how do I get rid of the 2 plus a? Well, it relates to the y by multiplication. So what undoes multiplication?
Dividing.
Yep, so we're going to divide both sides by 2 plus a. Now we rewrite it, and that's it. Because the 2 plus a's here, see, they cancel, right? Those can cancel out. And we are left with y, which is what we want, on the left-hand side. What does that give me now on the right? Yep. Plus 7, yep, over 2 plus a. And that's it. We're done.
Now we cry, right?
Well, you're only going to have 3 of these. So, or 4 of them in your homework. I'm going to do 2 of them. So you're only going to have to do 2 that are even kind of like this.
So cry at home. Got it.
Well, only 2.
I'm
I
kidding.
know,
I
I
was
know.
messing with you.
I know.
That was from Jerry Vincent.
Yes.
Write down the problems and he cried.
Well, you shouldn't have to cry in this class, hopefully.
Well,
so.
he told me
I
to
know.
tell you that. He thought you'd get a kick out of that.
All right. So let's now look at some of our homework questions. And there are 4 of these, 1 through 4. I am going to work out one of each. So I'm going to do question 1 and 2, because those are similar. 1 matches up with 4, and 2 matches up with 3. So this is going to be homework. (1.2). I'm going to look at question 1 first. And this is going to help you solve question 4. So 1 and 4 are very, very similar. Now, first thing we want to do, and this is, yep, your 1.2 homework.
Oh, 1.2.
Yep, 1.2.
Okay.
Okay, so what we want to do is we want to clear out our fraction. So this W, we can write this W as a W over 1, and then we can just simply cross multiply. So that's going to leave you then with WY equals 4y minus x. So cross multiply to get rid of your fraction. Very, very similar to question 4. Same concept, cross multiply. Now, what variable are we looking for?
Y.
So let's go ahead and put the y in boxes here. This one's actually easier than the last one. So what needs to be moved over? We want the y's to go together on the left-hand side. So let's move that 4y over. Now we've got wy minus 4y equals a minus x. Is everyone okay with that so far?
Yeah.
Now, what are we solving for? What
Y.
variable? Y. What do you notice they have in common on the left-hand side?
Y.
Factor out the y, and we're done. So then we've got y, and we've got w minus 4. The right-hand side is a minus x, and how do we finish it? One last step. Yep. Minus 4 on both sides, so divide by w minus 4. And now we've got our final answer, because those cancel. And we've got now y equals now a negative x over w what? Minus 4. That's it, and you're done. Question 4 is almost identical, just different variables. That is it. Instead of having w's and y's, you have c's and t's. Same concept though. Question 2. You've got 4k plus AR equals R minus 5y. And we're going to be trying to solve for the R. So let's go ahead and box them so we don't lose things here. So what's going to be our goal? What do we want to do? We want to get these blue boxes, yep, on the left. Everything else needs to go to the right. So let's begin by moving that R over. At the same time, that 4k, well, it doesn't belong here either, so let's move the 4k over so it goes to the right. Four k's can cancel, and so now you're left with AR minus R on the left. On the right-hand side, you've got minus 5y and a minus 4k. Is everyone okay with what I did there? So all I did was I boxed them and I said, okay, these two R's, they go together on the left-hand side. That's what I want. The 4k does not have an R in it, so it's going to have to go with subtraction on the right-hand side. Now what can we do?
Factor out
Yep.
that A.
Factor out, not that A.
Or
What are we solving for? The R,
R.
right? They have an R in common. And if you take it out and there's nothing left over, you leave a 1. So the R can come out. That's going to leave you with an A. And this R comes out. That leaves you with a -1. And we'll cover factoring in more detail in chapter 5 and 6. But that's its whole chapter. Now, how do we finish it? Last step here. Yep. Divide by A minus 1. That's it. We rewrite it, and now we're done. So now we've got R equals minus 5y minus 4k over A minus 1. We're now going to go ahead and take a short break. We're going to come back, and we're going to do the easy part of this section. We've already done the hard part. This was the only complicated part of this section. We're going to come back, and we're going to look at how to use these formulas, which is much, much easier. So let's meet back here at, let's say, 10:40. So let's meet back here at 10:40, and we should be able to get through 1, 2, and maybe start a little bit of 1, 3. We'll meet back here in about 10 minutes.